So let's start the lecture. It's finite sets. Finite sets. So you know the finite set, eh? So if there is a bijection from this set to the set of first some n natural numbers. Okay. So let's define it. Set is finite. Set is said to be finite. A set A is said to be a finite set, or it's said to be finite. Said to be finite if there exists there exists a bijection. If there exists a bijection, or you can say one correspondence. If there is a bijection f from A to this set 1 to n, okay, for some n greater or equal to 1. A set is said to be finite if there is a bijection, or अब यही है कि जो एम्प्टी सेट है उसको भी हम फाइनाइट सेट ही ट्रीट करते हैं. सेट सेट भी फाइनाइट इफ इट इज either एम्प्टी सेट or there is a bijection. Okay, okay, so clearly this if there is bijection from this A to set of n natural number, then we can say this cardinality of A is n in that case. So if A is the empty set, अगर ये empty set होगा, is the empty set, then we say cardinality of A is 0. Cardinality of A is 0, and if there is a bijection, there is a, or you can say in this this the first case, or there is a bijection, f from A to this set n, then we say cardinality of A is n. Then we say cardinality of A is n. Cardinality of A is n. अगर ये एम्प्टी सेट होगा उस केस में इसकी कोऑर्डिनेट 0 है, या अगर यहाँ पर आपके पास इस टाइप की बाइजेक्शन मिल गई किसी यानी के लिए, उस केस में हम कहेंगे कि ए की कोऑर्डिनेलिटी n है. ए की कोऑर्डिनेलिटी n है. तो इसके एग्जांपल्स, सिंपल एग्जांपल्स आप ले सकते हो. दिस इज सो ए इज दिस सेट से ABC. It's a finite set as we can define a bijection from this set A to the set of first 3 natural numbers by, can define it by f of A is equal to 1, f of B is equal to 2, f of C is equal to 3. Okay, so there is a bijection from A to this set, where here in this case n is equal to 3, and the cardinality of A is equal to 3 in this case. Okay, so the first lemma in this direction for finite sets is the following. So let n be a positive integer. Let n be a positive integer, and let A be a set, let A be a set, A be a set, let A be a set with A naught an element of A naught belongs to A. Then there is a bijection. Then there is a bijection F from A to n plus 1 elements, from A to this set 1 to n plus 1, if and only if देखिए अगर ये बाइजेक्शन होगी आपके पास, रिजल्ट ये है कि अगर आप इसमें से एक एलिमेंट काम करोगे, ए में से एक ए नॉट को बाहर निकालोगे और यहाँ से एक एलिमेंट काम करोगे, मतलब n plus 1 आप बाहर निकालोगे, then there is still a bijection from these two, between these two sets, if and only if there is a bijection, there is a bijection G from the set A minus A naught, इसको मैं A से बाहर निकालता हूँ, to this set 1 2 up to n. तो दिस लुक स्ट्रेट फॉरवर्ड है. अगर यहाँ से यहाँ तक बाइजेक्शन है, आप यहाँ से भी एक एलिमेंट बाहर निकालोगे ए से भी, और इस से भी आप जो लास्ट एलिमेंट इसको आप रिमूव करोगे यहाँ से. So there is still a bijection between these two new sets. So let's first assume that there is a bijection G. Okay, prove. So assume that G from the set A minus A naught to this set 1 2 n. Assume that this is a bijection, so assume करोगे कि ये bijection है. Now you have to define a bijection from set A to this set of n plus 1 natural numbers. So let's now define that map. So define f from A to this set n plus 1 by, how do we define it? It is it's f of A is equal to g of A. Okay, if A is not equal to A naught, क्योंकि A naught पर G डिफाइन नहीं है, G is defined from the set A minus A naught. Okay, तो जहाँ पर भी A naught के बराबर नहीं है, तो f of you take f of A equal to G of A, and how do we define this f of A naught? Let's take this as n plus 1. मतलब ये है कि आपके पास ये set A है, this is set A, and this is this set 1 2 then n plus 1, और ये set A है आपका, this is your mapping f. तो जो भी एलिमेंट से A is जो भी है, A goes to these elements, they all goes to the first n natural numbers. Okay, और जो last element है A naught, you map this element A naught to n plus 1. तो A minus A naught पर जो मैप f होगी, it's same as G. ये वही है जो G आपके पास ऑलरेडी डिफाइन है, which is a bijection. और ए नॉट पर क्योंकि जी डिफाइन नहीं है, वहाँ पर आप एफ का वैल्यू कैसे करोगे डिफाइन? लेट्स टेक दिस एज n plus 1. Then obviously f is a mapping from a to this set 1 to n plus 1, because g of a takes the values from 1 to n, and at a naught the value is n plus 1, so it's obviously a mapping between these two sets. And this mapping is 1 1, that's straightforward. If you take any two members from a, and if you take this f of a equal to say a1 and a2, f of a1 equal to f of a2, then obviously this a1 must be equal to a2. So that's a straightforward thing that you can do easily, and it's also surjective. So if I have any element in this side, you obviously have a pre-image. So या अगर आप इसको देखना चाहोगे, let's take any two elements. Let's take any two elements, say a and b in A, such that f of a is equal to f of b. Okay, f of a is equal to f of b. Now case 1, if both a and b they are not equal to a naught. Case 1, if a not equal to a naught, b not equal to a naught, suppose दोनों a naught के बराबर नहीं है, then what's f of a? Then in that case f of a is g of a by definition, and f of b is also g of b, but g is given to be a bijective map, so it's a 1 1, which means that a is equal to b. So in this case f of a equal to f of b implies equal to b. अब सेकंड केस अगर आप लोगे a अगर a नॉट के बराबर होगा सपोज, देन और b अगर b नॉट के बराबर, देन दिस इज नॉट पॉसिबल, या तो दोनों a नॉट के बराबर होगे या दोनों a नॉट के बराबर नहीं होगी. दिस इज द ओनली केस, दीज आर द ओनली टू केसेस. अब देखिए, अगर मैं बताऊंगा कि ये जो है a नॉट के बराबर है और b a नॉट के बराबर नहीं है, सी दिस, a अगर a नॉट के बराबर है, ओके, a अगर किसके बराबर है? a नॉट के बराबर, उस केस में f ऑफ a नॉट जो है वो n प्लस 1 है, और b अगर a अगर a नॉट के बराबर है, उस केस में f वैल्यू जो है a नॉट का वो n प्लस 1 है, ओके. और b अगर a नॉट के बराबर नहीं है, तो b का जो f वैल्यू है दैट्स इक्वल टू g ऑफ b, और g ऑफ b के जो वैल्यूज है वो 1 से लेकर n तक है, और मगर जो a नॉट पर जो वैल्यू आपने लिया वो आपने n प्लस 1 लिया, और ये गिवन है, आपकी एजम्पशन है कि f ऑफ a f ऑफ b के बराबर है. तो अगर आप मानोगे कि a नॉट के बराबर है, तो f ऑफ a नॉट का वैल्यू आ जाएगा n प्लस 1, और आप ये मानोगे कि b नॉट के बराबर नहीं है, उस केस में f ऑफ b का वैल्यू जो है इट्स g ऑफ b इन दैट केस, और g ऑफ b के वैल्यूज जो है वो 1 से लेकर n तक है, और यहाँ से तो ये n प्लस 1 आ गया है f ऑफ a, और f ऑफ b जो आ गया it varies from 1 to n, so these two cannot be equal. मगर यह हमारी assumption है, these two are equal. You have assumed that a and b are the elements in a such that they are equal. So it means that whenever a is equal to a naught, then b must be equal to a naught. So case 2, if a is not equal to a naught, equal to a naught तो आपने लिया है, then since f of a is equal to f of b, so it means that a is equal to a naught, आपको लेना है, a is equal to a naught, a equals to a naught, and since f of a is equal to f of b और a naught के बराबर है, a naught के बराबर है, तो इसका मतलब है कि b must be equal to a naught, b भी a naught के बराबर होना चाहिए. तो इस केस में भी आपका a जो है ना a b के बराबर है, so therefore a is equal to b. तो फर्स्ट केस a अगर a naught के बराबर नहीं है, उस केस में भी आपका a b के बराबर आ गया. सेकंड केस अगर a naught के बराबर है, उस केस में भी a और b जो है they are equal, so that means it is 1. एंड इट्स ऑल्सो सब्जेक्टिव भी है ये. सब्जेक्टिव के लिए आप कोई भी एलिमेंट आप वहाँ से लीजिए n से. सो लेट्स टेक एनी एलिमेंट x belongs to the first n plus 1 natural numbers. So case 1 if x varies from 1 to n, and second case if x is equal to n plus 1. So in both the cases you can find its preimage. So case 1 can discuss. If x belongs to this set 1 to n, okay, then there exists some a in a minus a naught such that g of a is equal to xy, because g, it is given that g from a minus a naught to the set of first n natural numbers is a bijection. और x आपने यहाँ से लिया है, so that means you can find element from this set a minus a naught such that image of that element under g is equal to x. Now this a is not equal to a naught, so, and whenever a is not equal to a naught, then g of a is same as f of a. So in that case f of a. So that means we have a preimage for this x under the map f. तो सेकंड केस, अब अगर x n plus 1 के बराबर होगा, if x is equal to n plus 1, then clearly this f of a naught is equal to n plus 1. So in both the cases we have a preimage of x under f in the set A. So that's this f is both 1 1 and on. Now it's converse. So this was very simple. That's this direct part. Now the converse part of this theorem. So conversely, we assume that there is a bijection. Conversely, assume that there is a bijection. There is a bijection f from A to this set n plus 1. सपोज ये बाइजेक्शन आपके पास है, इसमें भी हम फर्स्ट केस ये लेंगे क्योंकि ए नॉट ए में है, हम फर्स्ट केस ये लेंगे कि अगर ए नॉट की इमेज n plus 1 है. सो केस 1 if f of a naught is equal to n plus 1, अगर f of a naught किसके बराबर होगा, n plus 1 के बराबर, तो और कोई एलिमेंट ऐसा नहीं होगा a में जिसकी इमेज n plus 1 होगी, because f is 1 1 है. So सिर्फ a naught, then a naught is the only element having image n plus 1. Okay, this is it. So f of a naught is equal to n plus 1. Now let's try to define g. Define g from a minus a naught to by g of a, where a is in a minus a naught, is equal to f of a. And this is obviously well defined because this is obviously a mapping. Mapping तो है ही है, क्योंकि ऐसे जो भी a इस सेट में है a माइनस a नॉट में, उसकी इमेज अंडर f जो होगी वो 1 से लेकर n तक ही होगी. वो 1 से लेकर वो n plus 1 हो ही नहीं सकती. किसी भी कोई भी एलिमेंट जो a माइनस a नॉट में है, उसकी जो इमेज अंडर f होगी वो n plus 1 नहीं हो सकती. रीजन क्या है, क्योंकि a नॉट की इमेज n plus 1 है. तो दो एलिमेंट्स की इमेज n plus 1 नहीं हो सकती है अंडर f, because f is given to be a bijective map. It's a 1 1 map. So that means this equation, if you define this g by this rule, by this equation, it's well defined. It's well defined. तो well defined मतलब ये है कि पहले तो इमेजेस तो यूनिक ही होनी चाहिए. सेकंड, ये जो आप डिफाइन कर रहे हो ना, g of a equal to f of a, ये जो output है, this should lie in this set, so which is clear from this definition of f actually. Now this mapping, ये जो mapping है आपके पास, g जो आपने डिफाइन किया है, this is obviously bijective map. this is 1 1. If you choose any two elements in this set A minus A naught, say A and B, such that their images are equal, g of A is equal to g of B, then f of A is equal to f of B, which means that A is equal to B because f is given to be 1 1. And obviously it's on to, if you choose any element on this side, in this side, then you can obviously find some element, because f is bijective. आप इन n प्लस 1 एलिमेंट से कोई भी एलिमेंट चूज कीजिए, आपको प्री इमेज मिलेगी. अब आपने क्या किया, आपने सिर्फ ये एलिमेंट्स लिए 1 से लेकर n तक, क्योंकि यहाँ पर 1 से लेकर n तक आपके पास एलिमेंट्स हैं. नाउ यू चूज एनी एलिमेंट इन दिस सेट, यू कैन ऑब्वियसली फाइंड प्री इमेज इन ए. और वो जो प्री इमेज होगी वो ए नॉट नहीं हो सकती है, क्योंकि ए नॉट किसकी प्री इमेज है, n प्लस 1 की. सो दैट मीन्स वो जो प्री इमेज होगी वो a माइनस ए नॉट में होगी. So that the image of that pre-image under f is equal to the element जो आपने यहाँ choose किया है. But that f value is same as the g value by definition of g. So it's a surjective also. It's 1 1 as well as onto that means it's bijective. So clearly this g is bijective. Clearly g is bijective. Now अब केस सेकंड है. केस फर्स्ट वाज सिंपल. केस सेकंड में क्या है कि अगर ए नॉट की इमेज n प्लस 1 नहीं है, if f of a naught is not equal to n plus 1, say f of a naught is some m suppose. So where this m is not equal to n plus 1, so m varies from m equal to 1 2 और इनमें से कोई वैल्यू है. m is not equal to n plus 1. So what do you do in this case? Since this is bijective, f from the set A to the set of first n plus 1 natural numbers is bijective. This mapping is bijective, so it's on to. So it means that every element has preimage. In particular, n plus 1 has preimage. So we can choose a1 in A such that f of a1 is equal to n plus 1. f of a naught m है which is not equal to n plus 1, और f of a1 जो है वो n plus 1 है. So obviously this a1 cannot be equal to a naught, because f of a1 is not equal to f of a naught is not equal to f of a1. So clearly as f of a1 is not equal to f of a naught, because f of a1 is n plus 1 and f of a naught is the one of the integer which lies between 1 and n. So which means that this a1 it's not equal to a naught. They are two distinct points of the set A. So why can you say this? Have you any idea this why this a1 is not equal to a naught?
Because f is 1 1.
No 1 1, because f is a mapping here. Okay, so ये mapping की property है. It's not the property of 1 1 here. F is 1 1, that's true, but here we are applying the property that f is well defined, because the images of a1 and a naught under f is different. So that means elements must be different. Elements cannot be same. So one element cannot have two images. So this a1 is not equal to a naught. Okay, this they are not equal. अब जो केस 1 हमने किया था, जहाँ पर हमने ये बताया था कि अगर f की प्रॉपर्टी ऐसी हो कि f of a naught n plus 1 होगा, उस केस में हमने किया था. Now what we do, we define a map h which is bijective, और उस h की प्रॉपर्टी ये होगी कि h of a naught n plus 1 होगा, और then we can apply this case. क्योंकि अगर आपके पास बाइजेक्शन ऐसी होगी a से लेकर वो n plus 1 elements तक with the property that f of a naught is equal to n plus 1, then you can find a bijection from a minus a naught to the set of first n natural numbers. तो वो केस आपने किया है. तो यहाँ पर जो f है, f में यहाँ पर f of a naught n plus 1 के बराबर नहीं है, but here we construct a new bijection, a new mapping which maps a naught to n plus 1. So वो हम कैसे करेंगे? ये आपके पास ये set A है. This is the set A and this is the set of n natural numbers. Okay, So 1 2 किसी जगह यहाँ पर m है, then we have n, then we have n plus 1, और यहाँ पर आपके पास ये a1 है, a1 की इमेज क्या है, दिस n plus 1, और आपके पास a0 है, a0 की इमेज क्या है, m. Okay, right? So this is your bijection f, which sends a1 to n plus 1 and a0 to m. Now what we do, we change these two. हम एक नई मैप डिफाइन करेंगे. नई मैप क्या होगी, वो एफ ही होगी, मगर उसमें सिर्फ एक चेंज हम करेंगे. उसमें हम a1 की इमेज m लेंगे और a1 की इमेज m लेंगे, मतलब इनको इंटरचेंज करेंगे. a1 की इमेज m लेंगे और a0 की इमेज n plus 1 लेंगे. आपको बात समझ आ रही है? बाकी जो भी एलिमेंट्स है वहां पर इफेक्ट सेम रहेगा उस मैप का और f का. So we define h from a to set of these first n plus 1 natural numbers by we define this h by h of a is equal to same f of a. If a is not equal to a1, a is not equal to a0. And what's h of a1? H of a1 is we define it as m, and h of a0 इन दो पॉइंट्स पर हम इसको ऐसे डिफाइन करेंगे. Okay, so then this h is bijection because f is bijection. अब ये दो पॉइंट्स है, यहाँ पर सिर्फ हमने इंटरचेंज किया इनका रूल, बाकी कोई चेंज हमने नहीं की. ये जो है ना सेट, अगर आप ये दो पॉइंट्स उस सेट ए से बाहर निकालोगे a1 a0, वहाँ पर h बाइजेक्शन तो है ही, वहाँ पर वन कॉरेस्पॉन्डेंस है, बिकॉज वहाँ पर ये f ऑफ a के बराबर है और f बाइजेक्शन है. और जो दो और पॉइंट्स है a1 a0, वहाँ पर भी ये बाइजेक्शन ही है, क्योंकि वहाँ पर a1 की इमेज m है, a0 की इमेज n plus 1 है, दोनों डिफरेंट है. इमेजेस आर डिफरेंट. ओके, elements are different, images are different, so it's 1 onto there also on these 2 points. So then this h is bijection, then h is a bijection such that h of a0 is equal to n plus 1. वो जो केस 1 आपने किया, जहाँ पर आपने बताया था if f is a bijection from a to the set of first n natural numbers such that f of a0 is equal to n plus 1, then we can find a bijection from a minus a0 to set of first n natural numbers. So by case 1 there is a bijection, there is a bijection g from a minus a0 to set of first n natural numbers. So this is the proof of this theorem. So next theorem that I will state only here. So given a set A, there is a bijection from set A to set of n natural numbers, okay, for some n. So given a set A, suppose that there is a bijection. Suppose that there is a bijection. There is a bijection f from set this 1 to up to n. Okay, so that means this is finite set, okay, of cardinality n for some n greater or equal to 1. Now let's take any proper subset of A. B be a proper subset. Proper subset of A. Suppose B A का proper subset है. Then theorem says that there is no bijection from B to set of these n natural numbers. Okay, then there is no bijection. Then there is no bijection G from B to set of these n natural numbers. तो इसका कहने का मतलब है कि अगर A की कोऑर्डिनेलिटी n है, अगर इसका कोई प्रॉपर सबसेट आप लोगे, उसकी कोऑर्डिनेलिटी n नहीं हो सकती है. ये एक्चुअली प्रिसाइजली ये कह रहा है, क्योंकि अगर बाइजेक्शन होगी then the coordinality is n, क्योंकि he says that there is no bijection means that the coordinality of B is not equal to n, where B is a proper subset of A. But इसमें कंडीशन ये है कि provided that B is a non-empty set. Okay, क्योंकि B proper subset है A का, तो you can take B as a empty set also, but this is true for only non-empty set. अगर B proper subset है A का but non-empty, okay, then there is a bijection. Then there is a bijection. उस केस में bijection होगी, H from B to not this set of n natural numbers but set of m natural numbers, where this m is less than n, where m is less than n. कहने का मतलब ये है कि अगर B प्रॉपर सबसेट है A का, तो B की जो कोऑर्डिनेलिटी होगी वो m होगी, where this m is less than A. It is strictly less than A. Okay, तो ये आपके लिए असाइनमेंट है, डू दिस. और अगर आप इसका प्रूफ देखना चाहोगे, यू कैन सी द इंक्रीज, वहाँ पर आप इसका प्रूफ देख सकते हैं. इट्स वेरी स्ट्रेट फॉरवर्ड. ये इसी जो लेमा आपने अभी किया है ना, इस लेमा से ये फॉलो हो रहा है. Okay, so let's see one important property of finite set. So what's this? That's this theorem. If A is finite, then there is no bijection. If A is finite, then there is no bijection. There is no bijection of A with a proper subset of A, with a proper subset of A, with a proper subset of A. ये अगर finite होगा, then there is no bijection of A with its proper subset. Proof. So assume that B is a proper subset of A and it's a non-empty set also. Assume that. So first we assume that A is finite. A is finite. A is finite. Then by definition there is a bijection. There is a bijection F from A to set of these n natural numbers. Okay, so let's assume that B is a proper subset. Assume that B is a proper subset. Proper subset of A. Suppose A B का कोई proper subset है. आपको प्रूव करना है इस A से लेकर B तक कोई bijection नहीं होगी. There is no bijection between the set A and its proper subset. And let G be bijection. Let G be bijection from A to B. Suppose ऐसी bijection है, and let this be a bijection. be a bijection. Okay, so if this is a bijection, then अब आपके पास दो बाइजेक्शंस है. वन इज फ्रॉम दिस f from a to first n natural number, second is g which is from a to b. Okay, let's take since g is bijection, so then g inverse is also bijection. You know that inverse of bijection is bijection. G inverse from b to a is also a bijection, is also a bijection. So thus let's take the composition. Now we can define the composition of G inverse and F. So it's F G inverse. Okay, F G inverse. Okay, then this then F G inverse. F is bijection, G inverse is bijection. It's a bijection from B to set of n natural numbers. Is a bijection, is a bijection. What's B? B is a proper subset of A. और F क्या है? F is given to be a bijection from A to set of n natural numbers. और B proper subset है. इस proper subset से लेकर इन इसी set तक, set of n natural numbers तक आपको bijection मिल गई है. But by previous theorem this is not true. This cannot be happen. Which contradicts. Which is a contradiction. Which is a contradiction by above theorem. Which is a contradiction. Which is a contradiction by the above theorem. So this is a contradiction. Okay, so because we can't have a bijection B from the set of n natural numbers, while B is a proper subset of A, as F is already a bijection from A to set of n natural numbers. And from this result you conclude that the set of integers is not finite. Set of integers is not. That's the next theorem. Z plus, which is this set 1, 2, so on and so forth, is not finite. Is not finite. Okay. ये set finite नहीं है. This set's not finite. Proof. its proof is very simple. Let's take this set B, which is equal to Z plus minus 1. So that's what's B. B is actually this set 2, 3, so on and so forth. Then B is a proper subset of Z plus. Then B is a proper subset of Z plus. तो अगर B finite होता, then there cannot be a bijection from this Z plus to B. But we can define a map from Z plus to B, which is a bijection. So that means Z plus cannot be finite set. क्योंकि finite set के लिए अगर आपके पास A finite set होगा, you cannot find a bijection between A and its proper subset. But here you define a map from Z plus to B, where B is a proper subset of A. You define a map which is a bijection. So let's define that map. Define F from Z plus to B by, हाँ आपके पास कोई आइडिया है मैप को कैसे डिफाइन करें Z plus से लेकर B तक जो कि बाइजेक्शन भी हो? Define this by
f of x is equal to x plus 1.
Right. Okay. F of x is equal to x plus 1. So it's clearly a bijection. So we have a bijection between Z plus and its proper subset. That means Z plus is not a finite set. So then this F is a bijection. F is a bijection. F is a bijection, and therefore Z plus is not finite, and therefore Z plus is not a finite set. Is not finite. So now I will only state some results here. So the first theorem is that the cardinality of a finite set solve is unique. The cardinality of a finite set is unique. Okay. So we don't have two cardinalities for a finite set. कोई finite set होगा, आप ये नहीं कह सकते इसमें 4 भी elements है और 5 भी elements है. मतलब either it has exactly 4 or exactly 5 elements, not both. So cardinality of a finite set solve is unique. So जब भी आप counting करोगे किसी finite set की, तो अगर counting के दौरान आपके पास दो cardinalities आ गई, it means that कि counting में problem है, ठीक है. So that this the cardinality is always unique for a finite set. So next one is if B is a subset of finite set, then B is also finite. Subset of a finite set is finite. Okay, subset of a finite set is finite, and the cardinality of a finite set is strictly less than the cardinality of the set. If B is a subset of a finite set of a finite set A, then B is finite. Then this B is finite. B finite है. And cardinality of B is less or equal to cardinality of B. अगर equal होगा तो equality होगी. Is less or equal to cardinality of A is less or equal to cardinality of A. A is finite set. So next one which characterize finite sets, which gives the if and only if condition for a set to be a finite set. Let B be a non-empty set, then following statements are equivalent. Let B be a non-empty set. Let B be a non-empty set, then following statements are equivalent So the first statement is B is finite. B is finite. Second one is there is an injection, or you can say 1 1. There is an injection, or you can say 1 to 1 function from there is an injection 1 1 function. 1 1 function, let's write here from 1 1 function, say f from the set B to the set of some n natural numbers for some n. तो फाइनाइट सेट के लिए आपको बाइजेक्शन की जरूरत नहीं, आप सिर्फ अगर आप 1 1 मैप ही निकालोगे ना B से लेकर सेट ऑफ सम n नेचुरल नंबर्स तक, then you can say this set is a finite set. But we can't say this cardinality is n. Cardinality के लिए आपको bijection दिखानी पड़ेगी. Okay, so this is the criteria for finite set. So it does not say about anything about this cardinality. And third one, there is a surjection. Surjection means onto. There is a surjection. There is a surjection, or you can say onto function. Onto function. Onto function. Say h from the set of first n natural numbers. So here is the reverse. Okay, n to set B for some n greater or equal to. it's a home assignment. The proof is at page number 43. Munkar hai. You can see the proof at page number 43. So इसका जो proof है that's at page number 43 on Munkaris. So next one is the countable product, the finite product of finite unions and finite Cartesian product of finite sets or finite sets. अगर दो फाइनाइट सेट्स आपके पास है, इनका जो यूनियन होगा वो भी फाइनाइट होगा और उनका प्रोडक्ट भी फाइनाइट होगा. सो फाइनाइट यूनियंस एंड फाइनाइट कार्टेशियन प्रोडक्ट and a finite Cartesian products of finite sets are finite. Finite sets are finite. तो इसका भी जो प्रूफ है you can see it at same page number 43. So this was about finite sets. So in the next lecture we discuss countable set, that we'll discuss in detail. Okay, so finite sets के लिए मैंने कुछ चीज़ें आप पर छोड़ी है because it's not too difficult. So countable sets or uncountable sets that we will discuss in detail. Countable and uncountable sets. Then finally we will see the Bernstein theorem, Schroeder Bernstein theorem. So if you have any question, now I can discuss